Okay, so took a picture of my little small globe, and you can look through the sensor. You can see that it's not central. See if I've got another picture. There, it's slightly off. But these things are always a factor, aren't they? But useful in there's two different perspectives. Pictures. Anyway, my concentration is on Japanese, Tokyo to San Francisco. If you go look on the world map, you will find that just under this purple bit there, Tokyo is just there. This is as from the top as best as I could get it at the time. And we can do on that one there. We've got Japan down there. Also, I find the good thing about doing my videos this way is I can focus in on stuff and actually spend time explaining what I'm trying to do, and also just edit the videos in snips. Anyway, so San Francisco is just there. Let's say where that line meets the dark area. The dark area there, believe it or not, is the equator line of the globe I was using. I was trying to get it. I think I could see it. Anyway, the equator line's there. You can probably look at Yeah. Trying to get my bearings right here. Anyway, so we're looking at Japan, and Japan is there, the purple. So we count 1 zone, 2 zone, 3 zone, 4 zone, 5 zone, 6 zone, 7 zone, 8 zone, 9 zone, 10 zones. So it goes through 10 zones. So when people are saying those 10 zones there, well, what's the circumference going to be at 35 north? Well, realistically, I'm looking at a sphere from above. You can see where the shadow is. That's obviously not Earth. And I'm trying to talk slowly so I can explain what I'm doing. So the circumference of the equator is 40,000 kilometers. And the circumference that most people... Now, if I said to you, would be the circumference at 45 degrees north? Now, there is 0 at the equator and there's 90 at each pole. 90 north and 90 south. So halfway is 45. If you were to ask the average person that if the outside, which is where the equator is 40,000 kilometers, what's the circumference going to be at 45 degrees north? Now, there's probably a few of you watching this is thinking, I don't know too much about coordinates. I'll give you some layouts. So, UK. Okay, UK is there. All right. Maybe I've given it away too soon. Anyway, so the average person, I would ask, would say that it would be, you would think it would be half the diameter. Okay, so if you look at this and you see where half the diameter is, you would look at this line here. Yeah, where it says "See farewell." I'm just going on assumptions here. Look at the spacing between, you've got 2 spacings one side and you've got 3 spacings the other. So you'd probably say Iceland would be halfway. But Iceland can't be halfway. Iceland is about 65 degrees north. So it's not halfway. So please give me a thumbs up. Share my stuff if I'm starting to get, tell me if I'm doing the right. Tell me what I'm doing wrong. I'm trying to get concise, and maybe just read it back and say, maybe just edit your videos more, so you're not just cut out the crap and get to the point. Hopefully you've got some music on again.
Guarantee you haven't.
Still talking. Damn. yeah, so the problem is that 45 degrees north, believe it or not, is south of the UK. The UK, London, yeah, is, try and turn this picture upside down, I can't. London is 51 degrees north, so 45, with 45 be, you know, Morocco, Spain, Portugal. And then you start to realize, well, okay, so where's halfway then? Well, halfway is there. So that distance where that's, you know, where it says, does it say France? Yeah, France there, is that the 45 degree. And it's not degrees, they're parallel lines. Their lines are parallel, they're not degrees. Because in spherometry, degrees will not have equal spaces. It's rubbish. And yeah, so when you ask a person what the circumference will be at 35 degrees north, which is which we're concentrating on, San Francisco, just at the bottom of the orange bit there, where I'm trying to centralize things. That point there would be what I'm trying to point at in the middle of the screen. That's San Francisco. Japan in the middle of the screen. Tokyo. Okay, so we've got 10 time zones. We've counted 10 time zones across there. And if the circumference and the diameter would be the same as the equator, or very close to, it wouldn't be the same obviously, but very close to. And yes, you're going to say, yes, you're pulling in a bit, but diameter is diameter. And your perspective as well. There's nothing distorted here. So there's, okay, so when we are talking about the circumference and we're saying 35 degrees north, then your circumference is pretty much the same. So we go and look up what distance they covered, and we can move back to that. So this is that flight there, and it's left. Okay, so it's gone through 10 time zones, 9 hours 30 minutes. Okay, so 9 minutes early, blah blah blah, 9 hours 30 minutes. It does a northerly route. I don't know where I got that idea from, apologies. And starts at 140 longitude. It moves 100 degrees because you've got longitude of 140. Goes through the change of there. Where have I left? Did I start at Japan? Oh, my bad. You've got Japan to San Francisco. Yeah, you started for Japan. Tokyo 1034, 140 longitude. 140 goes up to 180, which is 40 degrees. Then comes down again to 140, which is 80 degrees. And then settles on 120. Almost. Yeah, so 98 degrees. So it's gone east 98 degrees. So it's gone east 10 steps and it's gone east 10 time zones. But a time zone is not 10 degrees wide. A time zone is going to be what? A time zone is going to be the circumference divided by 24. So each gap would actually be 16.6 degrees wide. Let's go back to this here. So your spacings at the equator are going to be 1,666 kilometers wide. I use kilometers because they represent the meter. The mile doesn't represent anything. just a nautical mile. The noughts feed the crosses. The noughts that could swim or sail the waters told the people on the land, these are the measurements. How do you measure a kilometer on water? How do you measure a kilometer in the air? You know, it's sort of second guesswork in ways. Anyway, and the spacings here, if the spacings at the equator are 1,666, and then we're assuming that if we go up to 35 north, are we assuming that it's going to go up to 1,000 across? So then when this does the journey, it should be 10,000. So let's get some measurements on how far they went. I'm just going back and forth the same 2 pages, and we get a actual of 5274. That's miles. 5274 miles times 1.6. That's 8438. So 8,438 over 10 time zones. 8,448. So each time zone is 834 kilometers. Yeah, because sorry if I'm hesitating. Apologies. It's hard to do this live. Okay, so if we've gone through 10 time zones of the equator, we would have covered 16,666 kilometers. If the circumference is pretty much the same, as you can see here, looking at a top angle of a globe that everybody should have in their house, or shouldn't have, and if it goes through 10 time zones, there should be the equivalence of near enough the equator. Sort of distance. Why? Because you're looking at an almost sphere, whatever. Oh, it's slightly blown out by a few kilometers. Yes, 40 kilometers at the equator or whatever. You know, hard to measure water. So if you were to say, well, they've done 10 time zones and they covered 8,340 kilometers, that was 834 kilometers an hour. And I'm saying here that seems that they should have covered twice that distance, or not, but not even close to half. Yeah. So working on diameters here, the diameter from the center to the equator isn't going to be that much different from the diameter to 35 degrees north. Because this is perspective, and this is just using, you know, geometry and just common basic logic. So the calculation should be that should be closer to at least past 12,000 kilometers, but it only covers 8,400. Also with a time difference of 1 hour from Pacific Standard Time, you've also got Pacific Standard Daylight. I think one is the when they do the DST, and one is not. Just it's the last letter. So the flight was 9 hours 30 minutes, and you could say, well, that's close to them doing 1 hour per thing, per time zone. But if that time zone is actually way more than 834 kilometers wide, then what the problem is that they are doing the outer circumference, but it's just not there. And the same thing I noticed with the south, in the southern hemisphere. I do a lot of maps, but I do a lot of notes on them and stuff like that, you know, to do a presentation. that looks as good as this. It's more a case of me doing the right stuff, taking pictures, and then talking you through it. So I'm gonna finish up soon on this. And if we can track a flight from start to finish, fair enough. But if we can't, then we have to have explanations for why there's missing stuff. Right, 10:34. The flight time was from 10:34 a.m. 12:01, 10:34 a.m. to 10:34 to 7:34. So that's 9 hours. 10:34 to 7:34 is 9 hours. Okay, so they covered those 10 time zones in 9 hours. Yeah, in 9 hours. You start to look at the kilometers per hour compared to the maximum that these things reach. Yeah, we've got 510. These are knots, and knots are just like miles in simple terms. 506. Maximum speed these things reach: 540, 563, 569. I've been doing this for years. 573, 576. This is not by chance. I've been doing it for years. This is how I came to understand 576. And by the way, there's only something like a 63 kilometer difference if you're traveling at 10 kilometers in the air or 35,000 feet. It's something like, I think it was even worse than that. It was something like 63 kilometers you'll be saving, or adding on actually over the whole circumference of the Earth of 40,096 kilometers. I found on Google once. Equator, I think it's 576. So we've got 576 knots. Okay. What is a 1.852? 576 knots. 1.6. That's 921 kilometers. If anyone wants to go into the nautical mile, not 576 times 1.852, 1066 kilometers per hour. So if we're traveling it's not traveling that speed, what's your average going to be? 500. So 926 kilometers, 500 what? Yeah, 900 an hour. Sorry, 926 kilometers an hour over the the average of 834. I've dropped this down to 500 and not 564, which where I had. So 576. Just start looking at the averages and start to see that these things are like doing some amazing things here. But over 10 hours or 10 time zones, and the circumference is pretty much close to the equator. Come on, man. It's like, this is the obvious stuff they've left for us, man. They're just sloppy, or they're sloppy on purpose. I think so, because it's just one big game. Monopoly, Cluedo, and Risk. Put them all together. That's how the elite play, man. Sports and stuff like that. Back in the day, that was their thing. 1800s was like sports, like who could win the World Cups and this, that, and the other. And those that won the World Cup had their choice, their say. And they had a right to change a law or something like that. I don't know. Change science, change education. This is your century for rule, and now we're coming to a new century of something else. Our century is actually the 2021, or is the exit going to be? We don't know what time frame we're in. Everyone's saying, "Oh, we use a lunar calendar." You guys don't use a lunar calendar. A lunar calendar is a cycle of 1,092 days. And it's, you know what I mean? That's a lunar calendar. 37 lunar months or something. Phases or in conjunction with the sun. Do all your studies on the celestials irrelevant of the sun. Irrelevant of the sun. No phases, no imposition in conjunction. No, it doesn't work. So 1034, yeah, 1034, where's the denominator? 1034, 1116, estimated last track time 11:16 a.m. Good to go for AM to PM. 11:16, no blues. 11:16, 11:16, 11:16, 11:16, and then 6. So it's 7 hours. Don't know where it is. 7 hours. Don't know where it is. And bang, come again from 6:30 to 7:30. Bang, we didn't know where you were. Bang, bang, 12,497, not 10,000. These things are going way high. Way high. The only way for me, like that something needs to go way high. But then that's just saying something. 12, 9, look, all the numbers are the same. They don't even vary. But they're checkpoints, you know, each minute, blah, blah, blah. 12,000, I would hate it, isn't it? What's 12,497? 12,000. Damn, lost my page. We'll be finishing up soon, so just hold on tight, guys. Hold on tight. Damn, 12,497. 12,497. 12,497 meters into feet. 41,000 feet. And it's got some inches as well. 41,000 feet. The human body would be destroyed at, I think it's something like 22 kilometers or 28 or 30 kilometers. I'm pretty sure it's like 22 is like when your water boiled. It's like, you know, an airplane is a Faraday cage. So you got 7 hours of missing track time. Like a good one. Etihad 507. Oh mate, yes, I'm remembering now. I've got distances, you know, the distances in Santiago and stuff. 11,340 kilometers. Santiago to Sydney. That's a QF 27. Was it 63? $151 is Sydney. Leaves gate is Sydney. I'm trying to remember. My distance should be 11,340. And we've got direct 7,054, but they're a bit more. 7,054 should be the same number. 7,054 times over 1.6, 11,286. It's close, it's close. But they ended up doing a longer journey. It's understandable. But trying to compare distances, and they go really south there. I'm pretty sure I've done this one. I took the anomalies, and then the distances should be 11,340. Yeah, I covered that. Okay. Yeah, the last one. Oh, I'm nearly done, guys. I'm nearly done. Etihad 507 and 506. Just to show, I can do Singapore, Cape Town. The 7 hours missing there. I think it was like even more than that. I might be able to fit into this presentation. So this is ADS. This is going from Sao Paulo to Addis Ababa, Habi, 5:57. Oh, there we go. First estimated 5:57. 1 hour later. This is from Addis Ababa, and you're going over Africa. Then all of a sudden, can't track you. Gets to 10,000 meters. Knots at 5:48. Also, watch some of them. They might take ages to get up to maximum speed. And other ones, they get straight up there, man. I mean, look at that. You're in the 553s already after 6:17. Jesus, mate. In 20 minutes, it already reached like almost maximum speed. 559, 620. 20, you know what I mean? 23 minutes, like maximum speed almost. It's like, lekker, yeah? Lekker. Then it goes to estimated. Last time, 6:56. Put some music on, eh? Put some music on. 6:56. And then, 6:56. Double check. Double check. 6:59, sorry. 6:56, yes, on the last checkpoint, yes. 6:56. And then 6:56. Double check that was a PM. And then that's a 6:56 AM. Yeah? Fuck me, George. Is there any changes in time that I didn't notice? Because we went from AM in the morning. Nah, can't. Nah, seriously. So 7 o'clock in the morning, nice and simple. 5 hours to lunchtime. So it must be 5 hours then. Oh, how come I missed that one? Oh, okay, it couldn't have been 12. Yeah, I thought so. I was like, what? 7 o'clock through to 12 o'clock. So 5 hours and 40 minutes off the radar. Speeds are lower than the fastest speed they got there, but they're probably trying to clear Africa really quickly before they get shot down. And then at 1:20 goes blue. So that's 2 hours of, and yeah, estimated. 20 minutes here and there, but still 5 hours and 40 minutes of estimation. And yeah, look at the top of your globe. Let's see if I can get that Singapore thing in. I'm going to go with this one. If I'm lucky, it's there. Singapore to Cape Town. Please give me something. Damn. South Africa. Johannesburg. You never get anything. God damn, it's so hard to get a South African. Singapore. Damn. To Cape Town International Airport. Tambo. Johannesburg. Please. You bugger. So typical. One last go. Singapore. You have to find the international airports. Yeah, I'll go with that one as a guess. And then I'm gonna stop now, but check it out, guys. Thanks.